Welcome back. This is part 2, talking about this review. So I have already drawn the zeros that we found on this 2, 3, and 5, 2, 3, and 5. The next thing we're going to do is find these max and min points. That's the only reason I haven't connected these already. Like, everyone can see that it's going to look like that. But I still want to find those before graphing, just because I like to be as accurate as possible, because I'm a geek and nerd, and I love being right. So the way you do that on a calculator is you go to calculate, which is on the trace button. So you go second trace, and we can find the minimum first. Let's just go to minimum and press enter. And it's going to ask for 3 things. Right now it's saying for the left bound. I kind of need to find this thing first. There it is. So we know the minimum is right where my finger is, right there. So if it says left bound, it just means go to the left. So like, just until it's obvious that you're somewhere to the left, it doesn't really matter how much, you press enter, and then it asks to go to the right. Notice it puts a little arrow up here, and if you go a little bit to the right of it and press enter again, it makes another one. So it's saying you want to find the minimum between those 2 points. And as you can see, the minimum we want is between those 2 points. So that's the whole left bound and right bound. After that, you can just go anywhere inside this section and press enter a 3rd time, and it'll tell you the exact minimum. And just round this as an ordered pair when you're writing it in your blanks here. So I'll just do the tens place, because why not? 2.45, so the 5 would round this up to a 5. And then negative 0.63. The 3 would round it down to a 6, so there we go. So 2.5 and then negative 0.6-ish would be about right there. All right, 0.6, it's a little bit more than a half down. For relative max, do the same thing. Second trace, and this time you go to maximum. The max is right here, so I'm going to go a little bit to the left, go a little bit to the right, then go a bit to the middle. And it tells me the exact minimum max right there is 4.21, so it goes to a 2, and then 2.11, so it'll stay a 1. So 1, 2, 3, 4.2, 1, 2.1. So it's going to be something like that. In terms of others points, there's, I don't know, if I really felt like being accurate, I could go to this table to look for more points. I'm honestly not going to care too much, because I think even like these one, like, I don't know, maybe 1.8 or something. 1, 2, 3, 4, 5, 6, 7. Nope, it's off the graph. So I'm just going to use these. I can see it's going to go floop-de-doop. Like that, and look, it looks like it. Yay. Okay, that's it for the first side. For the second side, it's just more practice of the same thing. So let's do it again. Maximum positive roots. These and negative roots. Once again, those are the keywords, positive and negative. That's the whole seeing whether they're positive or negative, right? The sign changes. If it's positive versus negative, you're counting how many times. Whereas the possible roots, this is the P over Q thing, right? Possible. Those are the keywords you really need to memorize. All right. So for possible, it looks like this is positive, this is negative, this is positive, this is positive, and this is positive. Yeah, so there's only one negative. And if you count the sign changes, it changes positive to negative here. It changes negative to positive here. This does not change. This does not change. And that's it. So it changed here. It changed here. That is a total of 2 times it changed. So the maximum amount of positive answers, that is to say the maximum amount of positive answers here will be 2. It could be less, but there could be 2. There's definitely not more. For negative, any even exponents stay the same. So this is even, so it stays positive. This is odd. Because it is odd, the 3 is odd. This will change from a minus to a plus. Even stays the same. Odd, because it's a x to the first, this will change to a minus. And this is just an x0, so it stays the same plus. And when you count, this does not change, this does not change, this does change, and this does change. So there are, once again, two places. So that means there could be up to two negative answers. Could be less, but there could be two. So there could be two here, there could be two there, or there could be less. That's what it's saying. For the possible roots, once again, that is the P over Q. In this case, P is 9, and Q, it looks like, is going to be 1 because there's no number in front. So 9 over 1. The things that go into 9 are 1, 3, and 9. Things that go into 1 are 1. So once again, it's pretty simple. It'll be 1 over 1, 3 over 1, and 9 over 1, which are just 1, 3, and 9. And once again, you make them all plus or minus. Please remember the plus or minus. If you forget it, you do lose points, because as we just set up here, there could be negative roots. So it could be -1, -3, or -9. And there's positive roots possibly, so they could be plus. So there you go. Now we're going to use our calculator to actually find them. So I'll zoom out a little bit more. And I'll go x to the 4th minus 5x to the 3rd plus 4x squared plus 3x plus 9. I'll double check that I plugged it in correctly. Good. Okay. And I'm going to look to see if there's anything that it obviously goes through, and it goes through 3. Looks like it definitely goes through 3. And sure enough, 3 was the possibility, right? It doesn't go through 1, it's not going through 9, so it's definitely a 3 that it goes through. More importantly, if you, you don't have to zoom in here, but I'm going to, just to show you. Because the other part that I didn't address on the front because it didn't apply was the whole multiplicity thing. If you zoom in here, which I'll even zoom again to show you. Boom, 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 boom. Normally, these things will come down and they will go through the x-axis and then come back up to have another solution over here or something. But as you can see, as I'm zooming in, it's not going through it. It's just kind of tapping right there and bouncing up like a ball. That is meaning it has a multiplicity. In most cases, it's a multiplicity of 2. So I would need to write that down. So 3 has a multiplicity of 2. Like so. So it's just important to note that it has a multiplicity. On the other side, none of them had a multiplicity, or rather they all had a multiplicity of 1, because this went straight through, this went straight through, and this went straight through. So all of them had multiplicity 1. So maybe I'll write that down. All of them had multiplicity 1, because they all went straight through. None of them bounced off like this. Didn't bounce off, didn't bounce off. They went straight through. But for now, I'll put this little thing right there. And, it's asking for end behavior again. By the way, if you need to zoom in or out, you press the zoom button. Zoom standard, the 6th one, is going to get you back to the regular kind of thing. We can just look at the end behaviors, which it looks kind of hard to see. So you can either guess that this one goes up to positive infinity. That one's kind of easy. This one, it can sometimes be hard because you technically don't know if it goes off the graph and falls back down over here. So I'll do this the old-fashioned way, which is you look at the degree. In this case, this is an x to the 4th function. The highest degree is 4, which matters because it's even. Any even degrees mean that the end behaviors go in the same direction. It's also noteworthy that this is positive x to the fourth. Anytime a function is positive in the front, that means it's always going to end going up. Because it's positive, it goes up on the right side. And as I said, since it's an even exponent, that means the other side has to go the same direction, which means both ends are going to be positive infinity. Okay. Relative max and mins. It looks like there's two relative minimums. So there's a relative min here at negative 0.2, 8.6. But there's also another one right here. I don't really need to do the calculate. You could, and you'd end up with something, but 1, 2, 3. This is 3, 0. Since it bounced right there, that has to be 3, 0. So there's another minimum at 3, 0. And the relative max, you can't physically see it because it's like going to be up here, but you can still go to the left of it and press enter. You can still go up until it calls back down and make sure it's on the right side of the 0, and then you just go anywhere and it'll still tell you the max, which is, it looks like 112. Yeah, if calculator ever shows something like this, it just means like the way a calculator finds it through their algorithms means it should probably just round to a 1. It's very, very unlikely that it's actually 1.000001. And there you go. So yeah, it just kind of looks like this is going to be at 1, 2, 3, 4, 5, 6, 7 off the graph. So I'm just going to go like this. Woo! Bouncy, make a bouncerson. Woo. Okay, there you go. It looks mostly like it now. We're good. Yeah, there you go. That's that one. And I guess we'll come back to do the next one later. Oop, no, I had to do one more thing. My bad. Okay, so there's more solutions. There's more zeros, right? 3 is the only real solution, but you can still find more using synthetic division. If you use synthetic division, 1, 5, 4, 3, 9. And synthetic division, you drop down the 1, multiply, and add. Multiply. I feel like I'm doing something wrong. Did I copy a number down wrong? I did. I'll address it in the next video. I think I can't see what's in here anymore. So hold on a second, we'll be back for part 3.